𝐴𝐸𝐶 and 𝐵𝐸𝐷. So this is 𝐴EC and you have BED are chords of a circle, and AE is x plus 5 centimeters. So it's this bit that's x plus 5. Then CE is this bit, so that's 5x minus 12 centimeter, and DE, which is this part, that's x plus 12 centimeters, and we've been given angle DAE is 48 degrees. We need to work out the size of angle ADE. So how do we start with this question? Now, obviously, being within a circle, there has to be some use of circle properties. So I would look into, what circle properties I could use. So it very much looks like angles within the same segment are equal. Now, which angle would it be, and how does that help us? Well, to find that, the one thing we can start with is to join BC. So if you join BC, you do get a lot of angles that would be equal, beginning with 48 degrees. So you get angle DAC is equal to angle DBC is equal to 48 degrees. Now that doesn't help much. It doesn't give us what angle AD is, but what it does do is it gives you two triangles. This is, say, if this was alpha, this would also be alpha, and this two angle would be equal to vertically opposite angle. So it gives you two similar triangles, and then using the properties of similar triangles, you can find out what x is. If you can find out what x is, then you can use the, I thought we could use the law of sines instead of the law of cosines. So it would probably be easier to use a law of sines. So that's what I did. Start with joining BC, and then assume that angle ADB is alpha. See, ADB is equal to ADE, so that's alpha, and is equal to angle ACB. Okay, and then angle in the same segment, that's a reason. Okay, they're all in the same segment. This is the same segment, and the other one, the 48 and 48, is in this segment. Okay, so next we have got angle AED is equal to angle BEC, vertically opposite angles. Triangle AED, that's this triangle, is similar to this triangle, and since they are similar, so we can apply the property. So that is BE out of AE. So you have to be a bit careful about which sides do we say are proportional. So if the angles are equal, two triangles are similar, if you just put one triangle on top of the other and see which angles match, you would get the proportional sides. So it would be AE is proportional to BE, and DE is proportional to EC, and then you'd have AD, of course, is proportional to BC. In this case, AD and BC are not of much relevance. But anyway, so BE out of AE, so you get BE out of AE is equal to CE out of ED, and then you can write down the side lengths now. So x out of x plus 5 equals 5x minus 12 divided by x plus 12, and you go on to solve for x, and you see x cannot be negative, so therefore x is 3.75. So once you know x is 3.75, what you can do is you can then find out what the actual side lengths are. So the side lengths are, we are interested in DE and we are interested in AE. So we got those side lengths. Now we have to apply the law of sines, which is sine 48 degree divided by the opposite sides, which is DE, and that is 15.75, would be equal to sine alpha divided by 8.75. And then if you go on to find, you would get alpha is equal to 24.4 degrees. Correct to 1 decimal place, and that is the answer.